Hello and welcome to Functional Skills Maths. Today we're looking at the topic of surface area. Now I'm just going to share my screen with you here. But this is a level 2 topic, and this is one that you should probably consider after having a look at perimeter, area and volume. So once you're secure with all of those, I'd recommend looking at this area next. Now, finding the surface area of 3D shapes, there's quite a few that you may be asked to find within an exam. Now, these include cuboids, triangular prisms, cylinders, and spheres. So all the shapes that we've looked at before for volume and things like that. And by the end of this session, you'll be able to figure out how to calculate the surface area for each of those different shapes. Now, surface area, what is it? Well, you can think of it a bit like wrapping paper. Is how much wrapping paper do I need to cover this surface exactly, or to cover this shape exactly? So, different shapes will have different approaches and different formulas that you need to consider when dealing with them. So first of all, we're going to take them, we're going to take them one by one, but we're going to look at cuboids. So here we have a box, a rectangular box. Nothing special about it, really quite ordinary. But how do we work out the surface area of this shape? Well, we can start by thinking about the shapes in terms of how many faces there are on this box. Now, what we have is we have a front face. And this point here says that every face has one exactly the same as on the opposite side. So we have the front face, and the same size is on the rear of the object, at the back here. We also have a side end, which again has an opposite on this side, out of view in the picture. We also have the top, and again, the opposite and the same on the bottom as well. So we essentially need to work out the area of these three sides and then times each one by 2 to account for the opposite one. So let's do this one by one. Put some measurements on it. First of all, length of 10, height of 4, depth of 5. Now, if we take the front face, what we need to realize, to work out the area of this face, we do length times width. So that's 10 times 4, which gives us 40 centimeters squared. But because there's two faces, remember, we've got the opposite one as well, we then have to do this little times 2 bit in the calculation, which means that we end up with 80 centimeters squared. That's the front and back combined. Okay, on the side, on the right-hand side there, it's just shaded dark purple. We need to calculate the area of that side. That's a height of 4 and a depth of 5. So 4 times 5 is 20. And then there's two sides because it's got the opposite. So 4 times 5 times 2 gives us 40 centimeters squared for the ends. And then finally, we'll look at the top. And that is obviously a length of 10 and a depth of 5. So 5 times 10, and again times 2 because of the bottom face as well, which is its opposite. So 5 times 10 times 2 is 100 centimeters squared. And then we just add all of these three numbers up together, which tells us that the total surface area of this cuboid is 220 centimeters squared. And once again, we're dealing with a little 2 on the end because we are talking about surface area again. We're not interested in the contents or the volume. We're interested in the flat two-dimensional amount of space or the amount of wrapping paper that we might need to cover this object. So hopefully that makes sense here. For the cuboids, this is the principle. You've got 3 different faces, times each one by 2. Once you've worked out the area, then add them together. Okay, on the next slide is a few examples. So I'm just going to give you 10 seconds to work out the first one. I'll run through the answers. You can press pause if you like. You probably need to because it'll probably take a little bit longer than that to work it out. But I'll give you 10 seconds now. We'll run through the answers shortly. Okay, how did you do? So first of all, the front face is 9 times 5, and then there's 2 of them, so times 2 gives us 90. The side is 9 by 6 by 2, so the 2 sides gives us 108, and then we have the top, which is 5 by 6, and again by 2, the bottom as well gives us 60, altogether giving us a total surface area of 258 centimeters squared. Okay, let's have a look at the next one. I'll give you 10 seconds again. Okay, so how did you do? Well, the top of this is 3 times 12, and then times 2 for the top and the bottom, 72. The side is 3 times 4 times 2 for the 2 sides, that's 24. And then finally, the back and the front is 12 times 4 times 2, gives us 96 for those sides, and that gives a total surface area of 192 centimeters squared. Okay, hopefully you got those correct. If not, please take a little bit longer, press pause, just check your workings out now, just make sure that you've got each side listed down, and it might help you to draw them out, and then perhaps to shade them in or color them or put arrows by them and label them or something, top, sides, front and back, just to make it a little bit clearer, because sometimes this can get a little bit visually confusing at times. So sometimes just adding in bits of color, like we saw on the previous slide, bits of color or arrows can help us to sort of break these shapes down into their 6 different sides. Okay, we're now going to look at the next shape that we come to, which is triangular prisms, and how to work out the surface area of a prism. So here we have a cross section of a triangular prism. How many sides are on this shape? That's the first thing to think about. Let me just give you a few seconds to think about that, actually. Have you counted them up? Well, hopefully you'll see there's 5 sides. There's 2 triangles, one at this end, one at this end. There's the base of the shape. There's the back, the straight side here, and then there's the slanted side. So 5 sides in all. So that's what we need to work out, the surface area for each of these 5 sides. So let's start with the triangles. So the triangles, as we've seen before, when we were looking at area of a triangle, we need to use that formula again. So base height divided by 2 would give us the area of one triangle. So in this case, 6 times 8 divided by 2 would give us the figure of 24, and that's just one triangle. We have 2 triangles, so therefore we have to times it by 2, which gives us 48 centimeters squared. Okay, we're then going to look at the base of this triangular prism. Now, this is a rectangle, and the length of it is 20, the width of it is 6, so 20 times 6, or 6 times 20, gives us 120 centimeters squared. We'll then look at the back edge of this triangular prism. Once again, the length is 20, and this time we're dealing with the height, which is 8, so 20 times 8 is 160 centimeters squared. And then just one more side to go, which is the slanted side. And once again, the length is 20 centimeters. This time the width is 10. So 10 times 20 is 200 centimeters squared. Now that we've worked out the areas for all of the different sides, we can add them together, giving us a grand total surface area of 528 centimeters squared. Okay, if you want to press pause just to go over that again, just to make sure that that's secure in your understanding, then please do. But if you feel confident, then let's move on to the next slide and there's a couple of examples for you to practice. Okay, so take a look at the first one here, the purple one at the top. I'll give you 10 seconds. It's going to take you longer than that. So please press pause and we'll run through the answers very shortly. Okay, so that's 10 seconds. How did you do? Well, if we break it down, we work out the triangles first of all. So I'm not going to give you the answer straight away here. The triangles first of all, 8 times 6 divided by 2 for 1, and then times 2 to get the other one as well, gives us 48, same as in the last example. And the base is 7 times 8, which is 56. The back is a height of 6 times a width of 7, that's 42. And then the slanted side is 10 times the width of 7, which is 70. Add them all together, should give you a total surface area of 216 centimeters squared. Okay, let's have a look at the next one. So I'll give you 10 seconds again, but please do press pause and we'll review the answers in a moment. Okay, great stuff. So once again, let's go through side by side. So the triangles, first of all, 0.6 times 0.8 divided by 2, and then times 2 is 0.48 meters squared. The base is 0.6 wide by 2.8 long, and then 1.68 meters squared. Now the back, well, actually, you may have noticed that there isn't a back in this triangle. We don't have a flat side because we're not dealing with a right-angled triangle. So we can just ignore that one for now. What we've got instead is 2 lots of the slanted side. So we've got a length of 2.8 and then a width of 1. And then, as I say, we've got 2 of those. So that gives us 5.6 meters squared for those 2 sides. Add it all together, we have a total surface area of 7.76 meters squared. Very good if you spot the difference with that one. Now, just take a moment again if you want, just to reflect on this, just to process it, make sure that it's okay. There's a worksheet available for you on Padlet or from your tutor. So please have a go at those as well. And then send them back to your tutor when you feel happy with those. Okay, we're now going to look at the surface area of cylinders. Now this is yet another shape with yet another approach. So first of all, let's think of a cylinder. We have here a picture of a cylinder, modeling for us very well today. It could be a vat, it could be a tin of paint, it could be a squashed can of Coke, any number of things. Anyway, to calculate the surface area, perhaps the amount of decoration that we might need to apply to it, if we're giving it away as a gift, or wrapping paper again that we might need to put around it. To calculate the surface area, we need to realize that this shape consists of 2 circles and 1 rectangle. So we've got a circle on top, and the opposite side is the circle, same size. So there's 2 circles there. Then this wraparound bit in the middle, if you imagine taking a pair of scissors, if it was cardboard or something, and cutting it a straight line down, and if you unfolded that wraparound bit, you'd end up with a long rectangle. So we need to know the formula for the area of a circle, which is pi r squared. And then once we found the area of one circle, we can just times that by 2 because there are 2 circles here. So that's hopefully fairly straightforward. If you've done the module on area of circles, then you'll be happy with this. If you're a little bit hazy, then I'd suggest maybe go back, watch the video again, perhaps on perimeter and area of circles, or look at your notes from previously. but pi r squared is the formula for the area of the circle there, which means pi times radius times radius. Then to find the rectangle, the way that we do that is c times h. What on earth is that? Well, that's the circumference times the height. Now, we're using the circumference of the circle to tell us what the length of this rectangle is, because if you can imagine that we've cut it down here and then laid it out, folded it out, well, the length of that rectangle would be the length of the perimeter of the circle. Again, if you're not sure about the circumference of a circle and how to work it out, then please watch that same video on perimeter and area of circles. Very useful. Or revisit your earlier notes, because it's crucial that you have a good understanding of those two concepts to be able to work out the surface area of a cylinder here. Just as a quick reminder, circumference is pi times diameter. Anyway, let's put some measurements on this now, and then we can work this through as a practical example. So let's say that the radius is 4 centimeters and the height is 5 centimeters. Okay, to work out the circles, what we do is 3.14, which is pi, and then times 4 times 4, because we're squaring the radius. That tells us the area of one circle, and then we times 2 afterwards because there are the two circles. So that gives us a combined area for both circles of 100.48 centimeters squared. Then to work out the rectangle, what we do is 3.14 times 8, that's pi times diameter, and then times 5, which is the height. And that gives us an area for the rectangle of 125.6 centimeters squared. Now we add those two together, we end up with a total surface area for this cylinder of 226.08 centimeters squared. Okay, so hopefully that makes sense there. We've got two circles and a rectangle. And here in the brackets, we have the formula for the area of a circle. And here in the brackets, we have the formula for how to work out the circumference of a circle, pi times diameter. Diameter, of course, is twice the radius. The radius is 4, twice that is 8. As I say, please refer back to the video on area and perimeter of circles if you want to revisit those topics. Okay, let's move on and have a look at a couple of examples for you to try. I'm going to give you 10 seconds as per usual, but again, please feel free to press pause. You'll probably need a bit longer than that to work it out. So here we go. Okay, so that's the 10 seconds for the first one. We're going to look at this light blue one here. So what have we got? We've got an answer of 527.52 centimeters squared. Well done if you've got that. Now the way that we got there was by figuring out the circles, which is pi r squared times 2. So 3.14 times 6 squared. 6, of course, is the radius because we've been given the diameter. And half of the diameter is the radius, so half of 12 is 6. So pi r squared at 3.14 times 6 squared, then times 2 for the top and the bottom. It was 226.08 for that, for those shapes. And then the rectangle is pi times diameter, so 3.14 times 12. That gives us the circumference, and then times 8 gives us 301.44. And add them together, and that's how you get the 527.52. Well done. Let's have a look at this long, tall, dark blue cylinder here. Then I'll give you 10 seconds again. Press pause. We'll run through the answers shortly. Okay. So the answer is 20.02 meters squared. Well done if you got that. And again, just to break it down, the circles, pi r squared, 3.14 times 0.75 squared, times 2, because 2 of them, gives us 3.5325 meters. squared, and then the rectangle is pi times diameter, 3.14 times 1.5, and then times the height, which is 3.5, gives us 16.485. Add them together, you end up with 20.02 to 2 decimal places. Well done. We're now going to move on to the final shape for today, which is spheres. And happily, this one is a little bit easier in some ways than some of those previous ones. The formula here is 4 pi r squared. So again, you'll probably recognize that pi r squared section as being like a circle. It crops up quite a lot in maths. But 4 lots of pi r squared is essentially what we're calculating here. Now, in all honesty, you could do pi r squared times 4. It doesn't really matter which way around you do it. But the way it's written, 4 pi r squared is there in front of us. And again, this is one of those formulas that you will be given in the exam. So you don't need to remember it. You just need to have the confidence with how to read it through and work it through. What this means, of course, is 4 times pi times radius times radius. So let's put a number on the radius. Let's say it's 1.5 centimeters from the middle to the edge. Then how we would calculate this is as follows: 4 times 3.14 times 1.5 times 1.5 equals, in this case of this little marble, 28.26 centimeters squared. Okay, so take a moment and just take that in if you need to. Press pause if it helps, just to think about what we've done there. And then I'm just going to bring up 2 examples on the next slide you can work through as well. And I'm just going to bring up the formula again, just over on the right-hand side. As I say, it will be given to you in the exam. So back to our football again. What's the surface area of a football? What's the amount of leather covering that it needs? So I'll give you 10 seconds, see if you can work it out. Okay, so 4 times 3.14 times 11 times 11 should give you 1,519.76 centimeters squared. And that is how much leather is required for a Premier League football. Okay, and then the next example at the bottom, 34 meters is the radius. I'll give you 10 seconds, let's see if you can work it out. Okay, so 4 times 3.14 times 34 times 34 gives us 14,519.36 meters squared. If you've got those, excellent, you're doing really well. If not, then please just pause the video, rework them again, just to double check that your process is right and you're working this formula through correctly. And there's also a follow-up worksheet that you can do available on Padlet or from your tutor. Please return it to them afterwards and they will mark it for you. Okay, so well done. Quite a meaty and complex topic today, really. So you can now find the surface area of cuboids, triangular prisms, cylinders, and of spheres. And each one of those has got different approaches that we must use and some different formulas that we must consider as well. So you've done well to follow this through. Please revisit this. Don't let it slide. Just keep it in the forefront of your minds. Some of these formulas will be given to you in the exam. In fact, the triangular prisms will and the spheres will. But the cylinders and the cuboids most likely won't be. So you do need to remember those two, but the prisms and spheres, they will provide for you. But well done for today. Thanks for joining me. And may I wish you all the best with the rest of your functional skills.